All right, ladies and gentlemen, lesson 10.7. We're going to continue working with similar figures in the world of sort of geometry, but here we're going to discuss what we call indirect measurement, is being able to find the lengths or sizes of objects without going out and actually being able to measure them, say with a tape measure or with a ruler or a yardstick or something like that. And so what we're going to do is we're going to apply properties of similar figures. Again, that corresponding sides are equal or proportional, I should say, and using those topics that we've been dealing with in the last, say, 3 units, put into application, sort of out in the real world type of a thing. So, first of all, indirect measurement definition is a way of using properties of similar figures and proportions to find a measure. Again, without being able to directly measure the object. Okay, so we're using other means to find the information that we want. So, okay, here's an example, and you can do this if you want to, if you get a chance to go out and try this on some sort of an object. But we have a tree, and we want to find the height of the tree, but we're not going to say, in this case, say we can't go up the tree and actually figure out how tall we can, or how tall it is. So we're going to use other means. In this case, we're going to use a person, and we're going to use shadow. Okay, because and obviously it does take a sunny day to do this, but you can do this if you want to find the height of an object. So let's say that we have a man, a person, and then we know their height because we can measure the man. In this case, we're going to say 6 foot tall. He casts a 4 foot shadow. The thing we have to realize, and let me draw a little bit of a picture of here. Up over here somewhere we have the sun casting a shadow, okay? And, well, with its sunlight coming down, and it casts a shadow. And so because the angle of the sun to the man and the angle of the sun to the tree are the same, the proportion, basically what we're getting here is, and we are getting a right triangle to be, now this is not drawn to scale, so it's not perfect, but since the angles end up being the same, we end up with similar triangles, okay? So I can set up ratios of corresponding sides. In this particular case, we have the height of the tree, whatever that is, I'll call it H, corresponds to the height of the man, which gives me a proportion, a ratio, sorry. So the height of the tree compared to the height of the man, that is proportional to the shadow casted by the tree, which is 15, over the shadow casted by the man. Now understand a couple things. This is not the only one that we could write. We could flip both of these ratios upside down if we wanted to and go 6 over H and 4 over 15. We just have to make sure that whatever order we go in, we follow that order all the way around. And then it's just a matter of doing cross products. Okay, 4 times H is 4H. Get my little butterfly here. 16 times 5, well, 6 times 5 is 30. Carry my 3. 6 plus 3 is 9. And then if I divide by 4, H equals, let's see, well, 4 goes into 9 twice with 1 left over. 4 goes into 10 twice with 2 left over. 4 goes into 20 5 times, so 22 and a half feet. Now, if you wanted to do that as improper, reducing improper fractions or mixed numbers or whatever, it's the same thing. But so 22 and a half feet in this particular case would be the height of the tree. And again, we're using indirect methods to measure how tall the tree actually is. Because again, in this case, say we can't get up there and figure out how tall it is. So, all right, another one, and this, you could do this as well. A scout troop wants to make a temporary bridge across the river. Okay, so in the blue in this case is signifying my river. Can draw a river very well in here, so I did this. Okay, so here's our river in blue. Okay, and we're trying to get across. This is where my bridge would go, where X is, but we don't know how long or wide the river is. The diagram shows the measurements the troop knows. Okay, the triangles in the diagram are similar. They're just flipped upside down. How wide is the river where the troop wants to make the bridge? So basically what they did is they said, okay, I don't know how long the bridge or the river is, but from the base of the bridge right here, they measure down a given length of space. Okay, in this case, they went down 42 feet and probably made a mark, or there was a landmark or something there for them. Okay, they then went a little bit further down and located another point, but in this case, they were able to then to make sure that these two were proportional. And it could have been a landmark or something, maybe a tree or some rocks or something like that. But because it's on the side of the river, they're able to actually measure these distances. Now, the one thing I do know in this case is the 18 of the little corresponds to the 42 of the big. Okay, those are the measurements across the bank. They also are able to step back away from the river, and this is in this case you're using sight lines, just like you were on the tree when you're sighting up to the top of the tree. They found themselves, and they were able to measure this 16-foot distance away from the bank, and use a sight line through to the opposite bank, where their other side of their bridge. That's what we call those things that go across rivers, of where the bridge is. Okay, so they know based on the angles that this angle here has to equal that angle there. We got a right triangle, we got a right triangle. The opposite angles then end up being the same. Okay, so using that sight line there through our object, like I said, tree, rock, whatever. Maybe they put a stick into the ground. They're able to create these two similar triangles. So again, my 18 corresponds to my 42. My 16 corresponds to the distance across the river. That is our unknown. And so at this particular point, we go ahead and just use our cross products and solve our problem here. So solve our equation. So 18 times x is 18x. All right. That is equal to 16 times 42, which I'm going to do the quick way. I got my handy dandy calculator right here, in this case just to keep things moving. 672 when I multiply 16 by 42. I then undo my multiplication of 18 with division of 18 on both sides of my equation. And 672 divided by 18, again punching it in just to do it quick, 37.3, and that repeats actually, feet. So their bridge needs to be at least 37, well actually a little over 37 feet long in order to get across the bridge. Which, by the way, this is something else that you could do yourself if you wanted to. You could make this work to figure out how far across a river you have. So, all right, so that's going to get us to the end of this, and so your job is to use some indirect measurements. There definitely may be some questions and things you need to come ask me. So when those things arise, come get the help. So, all right, good.